set up. Okay, so in this chapter we're going to talk about strings and vectors. You've already worked with strings to some extent. For example, when you wrote programs that allowed the user to enter a file name, and then you opened the file of that particular name. So that was using strings. And it so happens that there are actually two ways of implementing strings. The first one is the, how should I say, the more old-fashioned way of implementing strings. That is the way that was already available before the language C++ in the language C. And if you remember that C++ is a conservative extension of C, so every valid C program must also be a valid C++ program. So therefore, the way to implement strings in C can also be used in C++. I don't normally recommend you to use that for most purposes. There are some library functions that do require a C string, they're called. So they're called C strings because that's the way strings were represented in C already. So I don't normally recommend using them because the string class, that's the second topic of this chapter, is much more convenient and will prevent you from making a lot of mistakes. But as I said, there are some library functions that just require a C string to be passed, and so you're going to have to work with them sometimes. And then in the last topic, we're going to talk about vectors. So let's start with the array type for strings, the C strings. For a C string, we use an array of characters. But not every array of characters is a C string. Then what is the difference, you might ask? Right? If we're using arrays of characters for the C strings, but not every character array is a C string, then what makes an array character a C string? What makes an array character a C string is that there is a certain string end symbol appearing within the declared size of the array. Yeah? So an array of characters is only really a C string if the string end symbol appears within the declared size of the array. One of the consequences, one of the immediate consequences of that is that if you want to store, let's say, 10 real letters in a C string, then you need a character array with 11 elements, because in order for it to be a C string, within the declared size, there has to be the string end symbol, and that takes one character. So if you have the full 10 letters that you store in there, then you need the 11th character for the string end symbol. Only then is it a C string. The string end symbol is written like this, \0, and it is a character. Remember, characters are also represented by bits. It's the character that is represented with all bits set to 0. So if characters use up 8 bits, then in the string end symbol, all those bits are set to 0. What that allows you again, and all bits set to 0, if you use that as an integer, that is the number 0. So that allows you to do some things well, I guess I'm going to wait a little before I tell you. Let's start with something else first. So let's visualize what a string looks like internally. Again, a memory diagram. If we have a string called whatever message, starting at some position, if we have this message, and message is initialized first of all, message is declared to have 20 elements, and it is initialized to hello. I can write this. This is basically just a convenience for writing this. Alternatively, I would have had to write this. Yeah? And you can see how much more typing that would be instead of that. Remember array initialization with the curly braces and then the individual elements listed separated by commas. So here these elements are characters. So it's the capital H, the lowercase e, the lowercase l, the lowercase l, the lowercase o, and the \0. That's automatically added. If you write it like this, it's automatically added for you into the characters with which message here is initialized. So we would end up with this. Oh no, no, right. That's what we would end up with, and of course the entire string is declared to have 20 slots, 20 elements. The array has 20 elements, so we have some space here that we're not using. C strings do use arrays, but when we talked about partially filled arrays and this number used technique, that's not the technique we're using here. So we're not keeping track of the number of array elements used from this 20 element array. Well, at least not in the sense that we're keeping the number. We are keeping track of how many elements are used by using this string end symbol. Everything that comes after the string end symbol, of course, is unused. If you think about it, if you would like an integer normally for the length, I mean, the alternative would be to keep the number of elements used. Then you'd have to keep an integer for every string. An integer uses 4 bytes if you're talking about 32-bit integers, compared to 8 bits for every character. So even an empty string, if you would use a counter to represent its length, would use up 4 bytes, because the integer for its length would use up that much. Whereas an empty string in this way of representing it can be represented by just the string end symbol, only 1 byte. So if you have a lot of very short strings from either empty or 1, 2, 3 characters in length, then it's much more efficient to store them in this form than it would be to store them with the counter.
How about space?
Space is represented like this, just 2 single quotes with a space in between. I mean, you can draw it like this.
And the enter, if there is an option for enter?
Enter. Enter is represented by this.
So that doesn't change. The only thing that changes is the \0.
Yeah. The only thing new here is this \0 that we're now using to indicate the end of the string. By the way, this is also called the null character. It's also called the null character, string end symbol, string delimiter, all interchangeable, all synonymous. If you have the slide up, then you will see that this inscription there, "Hi Mom," and there's some question marks behind it. You could draw those here too. These question marks, they indicate not that there really are question marks stored here. They indicate that we are not concerned with whatever is stored there, because any function, any operation that works with C strings, it will consume the characters only up to the string end symbol and will never go look beyond. So what is stored there is irrelevant. Even though it does form part of the declared size of this array, but what is stored there is really irrelevant, because no function that reads a string will ever read there. Okay. Well, to
Professor,
yes.
So does that mean that it also functions as a break?
Sorry.
Does it mean that also functions as a break, since it won't like continue reading after the what was that called again?
The \0.
Yeah, it won't continue from there. So
They will not read there.
so it's kind of like a break.
It's you could think of it like a break. Yes, it's a string end symbol, and the functions that process strings, they're all written in such a way that they check, is this a \0? And if they are seeing a \0, then they're taking this as you're done with your job. You have processed the entire string. So they end those functions. Okay, so the general pattern for declaring a C string is to have char as the data type, then the name of the string, then the declared size, but you have to keep in mind that one of those is used up for the string end symbol. So at most 19, I call them payload characters just to distinguish it from the length of the array. So at most 19 real payload characters could be put into this message, and then the 20th at position 19, of course, that would have to be used in that case for the string end symbol. But of course I can put shorter messages in there, and then the \0 will just come at an earlier position in the array, but that's fine too. The only thing that I cannot do, the only thing that would be illegal for me to do, is to try to put 20 actual payload characters into this array and then try to treat it as a string, as a C string. That would not work, because then it wouldn't be a C string, because within the declared size of the array, we would not have a string end symbol. Okay, I just show you this this way of initializing a string. So that's exactly what happens there on that slide. And yeah, with a shorter string like ABC, you can do the same. But obviously, if I would initialize it just like this, yeah. If I would initialize message with an array literal that doesn't contain a \0, then that would not give me a C string. because the \0 is missing. Yeah? Okay, that's it for today. See you on Wednesday.